I warmly welcome you to my YouTube channel. Thank you for coming. Remember to subscribe and give a like to this video you are watching. Okay, so in this video, we are going to revise Science Paper 2, the combination of different past question papers. Okay, so we are going to begin with this question. Okay, so this question is from matter. Okay. So question 1 reads, state the kinetic theory of matter. State the kinetic theory of matter. Okay, so what does the kinetic theory of matter states? Okay, so the kinetic theory of matter states that matter is made up of tiny particles that are constantly in motion. The kinetic theory of matter states that matter is made up of tiny particles that are constantly in motion. Okay. So in this diagram, we have substance A. Okay. So the statement on B reads, the diagram below shows the arrangement of particles of matter in substance A. The diagram below shows the arrangement of particles of matter in substance A. Okay, so this is substance A. So study it very well and see the arrangement of the particles inside. Okay, so question B1. Question B1 says, in what state is the above substance? In what state is the above substance? Okay, so you should remember that we only have 3 states of matter. The first one is solids, second one is liquids, and the last one is gases. Okay, so don't confuse the states of matter to the basic units of matter. Okay, so the basic units of matter are also different. The basic units of matter are molecules, atoms, and ions. Okay, so the state of matter in the above substance is liquids. Okay, so this is a liquid. The substance A was in liquid state. Okay, you can see that for example, that particle can move to that position, and that particle can also move to another position. Okay, question B2. If the temperature of the above substance is lowered, what happens to the arrangement of movement of the particles? If the temperature of the above substance is lowered, what happens to the arrangement and movement of the particles? Okay, so the particles of substance A will be more closely packed as compared to the previous state. Okay, so if you continue lowering, or if the temperature continues to fall, particles will be more closely packed as compared to the way they are here. Okay, so that is the arrangement. Let us also talk of the movement. Okay, how will be the movement? Okay, so under movement, the particles will slow down. Okay, the particles will slow down. They will move more slowly. And if the temperature continues to fall, if the temperature is lowered, okay, these particles won't even move, but they will just vibrate. Okay, question B3. Question B3. Okay, what change of state occurs when substance A is cooled? What change of state occurs when substance A is cooled? Okay, so when this substance is cooled, okay, for example, you put, this is a liquid, so you put it in a refrigerator. Okay, after some minutes, what will happen? Okay, so this the change of state will be solidification. Okay, it will be solidification. Okay, Name any 3 physical properties used to determine whether a substance is pure or not. Name any 3 physical properties used to determine whether a substance is pure or not. Okay, so when you want to determine the purity or a purity of a substance, so what should be determined? Okay, what should you use? Okay, so density of a substance. Okay, so you measure the density of what you want to know. Okay, also the melting point. Okay, the melting point. You should also measure the boiling point. Okay, so I can give an example of, for example, you found the boiling point of water to be at 140 degrees Celsius. Okay, instead of being at 100 degrees Celsius. Okay, so that will indicate that that water is impure. That water contains some impurities. Okay. Question B. Explain why solids have a fixed shape. Explain why solids have a fixed shape. Okay. So solids have a fixed shape because the force of attraction between particles are great. This results in particles having a fixed shape. Okay, so the force of attraction, the forces of attraction, or the cohesion force of attraction between particles of solids are great, hence having a fixed shape. Okay. B2. Explain why liquids flow. Explain why liquids flow. Okay, so liquids flow because the force of attraction holding them are lesser as compared to solids. Liquids flow because the force of attraction holding them are lesser as compared to solids. Okay. Question B3. Explain why gases can be compressed. Explain why gases can be compressed. Okay, so gases can be compressed because the forces which hold the particles together are negligible. The forces which hold the particles together are negligible. Okay, hence particles are much further apart from each other. Okay, so by negligible, I'm trying to imply that the forces are very, very small. The forces are even meaningless. Okay, so this is why gases can be compressed. The statement above reads, the diagrams below show atoms of sodium and chlorine. The diagrams below show atoms of sodium and chlorine. Okay, so on my left hand side we have sodium, the atom of sodium, and on my right hand side we have the atom of chlorine. Okay, the first question. State the type of bond that exists in the compound formed when the 2 elements combine. Okay, so we have 2 prominent types of bonding. Okay, so the first one is ionic bonding, and the second one is covalent bonding. Okay, so ionic bonding is the type of bonding that occurs between a metal and a non-metal, whereas covalent bonding is the type of bond that occurs between non-metals. Okay, so you all can agree with me that we have a metal here and a non-metal. So sodium is a metal and chlorine is a non-metal. Okay, so the type of bond, this type of bond qualifies to be called ionic bonding. Okay, question B. B1. Draw the structure of the compound formed when sodium and chlorine combine. Draw the structure of the compound formed when sodium and chlorine combine. Okay, so this electron in the outermost shell of sodium. Okay, so metals are able to lose electrons, while non-metals like this chlorine is able to gain electrons. Okay, so this electron in the outermost shell of sodium is going to be lost, and it is going to be gained by the outer shell of chlorine, since the outer shell of chlorine is only lacking one electron to obey the duplex rule. Okay, so this is the bond that is going to be formed, or the compound that is going to be formed. Okay, question B2. Question B2. State the chemical formula of for sodium chloride. State the chemical formula for sodium chloride. Okay, so sodium has a valence of 1. Sodium has a valence of 1, and chlorine has a valence of 1 also. So these two valences are going to interchange. Okay, they are going to cross interchange. The valence of sodium is going to come down to chlorine, and the valence of chlorine, which is also 1, is going to come to sodium down there. Okay, so these ones they are not even necessary. So the formula we have of sodium chloride, the chemical formula is just this, sodium chloride. Okay, so this is the chemical formula. Okay, C. Explain in terms of bonding and structure why sodium chloride has the following properties. Explain in terms of bonding and structure why sodium chloride has the following properties. Okay, so it is very important for you to note that these ionic bondings have their characteristics or properties, and when we also talk of covalent bonding, they also have their own characteristics or features that describes them. Okay, so explain in terms of bonding and structure why sodium chloride has the following properties. 1, a very high melting point. Why do ionic bonding have a very high melting point? Okay, so this is because of the strong electrostatic forces of attraction holding the ions in the lattice. Okay, it is simply because of the strong electrostatic forces of attraction. 2, high electrical conductivity when in molten. Okay, so when something is in molten, then it is in a porridge form. Okay, so high electrical conductivity when in molten. Okay, so when in molten, mobile ions are free to move, hence conducting electricity. The statement above reads: the diagram below shows a chromatogram obtained during the analysis of some substances. The diagram below shows a chromatogram obtained during the analysis of some substances. Study the chromatogram and answer the questions that follow. Study the chromatogram and answer the questions that follow. Okay, let us begin by studying this chromatogram we have. Okay, so we have these components, I'll call them components, okay? So we have A, B, C, P, Q, R, okay? We have the baseline where these components are starting from, and we have the solvent front, okay? So the first question, okay, so before we proceed to answering this question, there are about 3 types of chromatography, okay? So this is ascending chromatography. We also have descending chromatography, so expect that one to come in your paper. And we also have radio chromatography, okay? So you can also have a research on them, on those I've mentioned. Who knows, maybe one may come in your exam, okay? So the first question is asking to say, which of P, Q, and R is a mixture or are mixtures, okay? So, sorry, we have the statement here. A, B, and C are standards, okay? So A, B, and C are standards. These spots are standards, okay? Whereas P, Q, and R are unknown substances, okay? So these are what we are testing. They are unknown, okay? So the first question is asking to say, which of P, Q, and R is a mixture or are mixtures, okay? PQR is a mixture or are mixtures, okay? So if we want to answer, if you want to put the correct answer on this question, okay, you compare these unknown substances, which are PQ and R, to the standards, okay? So if they are in the same line, then we can conclude to say that they are mixtures, okay? So let us compare P. Is P, which is an unknown substance, corresponding to any standard here? Okay, A, B, C. So P. Okay, so you can use a rule in your question paper. You use a rule to measure very well. Okay, so P is one of the answer. P is corresponding to standard B, okay? Let us look at Q. Is Q corresponding to any standard here? Okay, but Q, I don't think it is corresponding. If it is, then you can tolerate me on this one, okay? It's tolerance, okay? So what of R? Okay, so R, the way I'm seeing it, it is corresponding to B. Okay, so P and R are mixtures. Question B. Which of the standards can be used to make substance Q? Which of the standards can be used to make substance Q? Okay, so the 3 standards A, B, and C. So which one is corresponding with Q? Which one is corresponding with Q? Okay, so C. Standard C is the answer. Okay, standard C can be used to make substance Q. So if standard C can be used to make substance Q, then it is one of the answers on question A. Okay, sorry. Okay, question C. Which of the unknown substances has a component whose RF value is different from the RF value of any of the standards? Which of the unknown substances has a component whose retardation factor value is different from the retardation factor value of any of the standards? Okay, so this question is simply asking the most soluble unknown component, unknown substance. Okay, so R is the most soluble component, and it has the highest RF value. Okay, so this is because it is the most soluble component. Okay, so a soluble component travels a great distance. Okay, question D. Explain why the level of solvent is kept below the baseline at the start of the chromatographic process. Explain why the level of solvent is kept below the baseline at the start of the chromatographic process. Okay, so this is to prevent the dissolving of the components into the solvent instead of moving upwards. Okay, so if the baseline, the solvent, the level solvent is kept below the baseline, then the components will dissolve in the solvent, okay, instead of moving upwards. Okay, so you can also expect a question like, why should the start line be drawn with a pencil and not a pen? Why should the start line be drawn? The start line we are talking about is the baseline here. Okay, be drawn with a pencil and not a pen. Okay, so to prevent having wrong results, since ink contains dyes that can contaminate the solvent. Okay, so the ink in the pen can contains dyes that can contaminate the solvent. Okay, another question is like, why should the solvent front be near the top of the paper at the end of the experiment? Why should the solvent front be near the top of the paper at the end of the experiment? Okay, so it's to ensure that the separation of the dyes is complete. Question 3. Why should the spots and dyes on the starting line or the baseline be small? Why should these dots we are seeing, these black dots we are seeing, be small? Okay, it's to prevent spreading of the dyes sideways, hence getting mixed up with other spots next to them. Nylon and terylene are polymers. Nylon and terylene are polymers. What is meant by the term polymer? What is meant by the term polymer? Okay, so a polymer is a large molecule made from joining together many small molecules called monomers. Okay, so when you join small molecules called monomers, the product is a polymer. Okay, so some may define a polymer as a long chain hydrocarbon. Okay, and some may want to know what a monomer is. Okay, so a monomer is a short chain hydrocarbon. Okay, so when you combine these short chain hydrocarbons, then you are making up a polymer, which is a long chain hydrocarbon. Okay, B. Apart from being polymers, give one similarity between the two. Okay, so one similarity between nylon and terylene is that they are polymers. Okay, now apart from being polymers, what other similarity do they share? Okay, so I'll give you these similarities. Okay, so both nylon and terylene are condensation polymers. Okay, and another one is both are synthetic polymers, meaning they are man-made polymers. Okay, so both are synthetic polymers and both are non-biodegradable. Both are non-biodegradable. Okay, meaning they cannot decay. Okay, so they cannot decay. Okay. C1. Which of the two polymers is a polyester? Which of the two polymers is a polyester? Okay, so terylene is a polyester. Okay. C2. Hence, draw the structure of the polymer showing two repeating units and circle any ester link on the chain. Okay, so terylene is a typical polyester with ester linkage. Okay, ester linkages. Okay, and nylon is a typical polyamide with amide linkages. Okay, so these are the differences I'm from explaining. So nylon has amide linkages, whereas terylene, which we've been told to display, has ester linkages. Okay, so that is an ester linkage, and this is a nylon, or sorry, an amide linkage. Okay, so this is the structure of terylene. Okay, and that where there is a circle, that is the ester linkage they told us to circle. The statement reads: nitrogen is used to manufacture ammonia as shown in the diagram. Nitrogen is used to manufacture ammonia as shown in the diagram. Okay, so in this diagram we have nitrogen and X. Okay, so these two were reacted, and we have Y degrees Celsius plus catalyst, Z atmospheric pressure, and the ammonia, now the product, which is ammonia. Okay, so here they were manufacturing ammonia. Okay, or we are manufacturing ammonia. Okay, the first question: name the process shown above. Name the process shown above. The process of manufacturing ammonia, what is the name? Okay, so this is the Haber process. Okay. B. State the substance represented by letter X. State the substance represented by letter X. Okay, so when you are manufacturing ammonia, two gases are reacted. Okay, so one of those gases is the nitrogen we are able to see. So now what is substance X? Okay, so this is hydrogen. Okay, substance X is hydrogen. C. Write the conditions represented by Y and Z needed for the process. Okay, write the conditions represented by Y and Z needed for the process. Okay, so Y is showing the temperature. Why? Because it is in degrees Celsius. Okay, so when you are manufacturing ammonia, okay, at what temperature should it be? Okay, so the temperature in some books it's different. Okay, some books shows different temperatures. Okay, so on this one there is tolerance. Okay, so they follow a range of answers. So but I will go for 400 degrees Celsius. Okay, so the temperature should be at 400 degrees Celsius, but in some books you will find 350 degrees Celsius, 350 degrees Celsius. Okay, and Z, the atmospheric pressure. So the atmospheric pressure is 200. Okay, it's 200 atm. Okay, D. or C, sorry. Write the condition D. D1, name the catalyst used. Name the catalyst used. Okay. So the catalyst, what is the name of the catalyst used in the manufacture of ammonia? So the name of the catalyst is ion. Okay. The catalyst is ion. So a number of transitional elements are catalysts. Okay. D2, write the many ore from which the catalyst named in D1 is extracted. Write the many ore from which the catalyst named in D1 is extracted. Okay, so iron is extracted from a chief ore called hematite. Okay, hematite. E, construct a balanced chemical equation for the reaction shown in the diagram. Construct a balanced chemical equation for the reaction shown in the diagram. Include state symbols. Okay. So when we react nitrogen and hydrogen, we are going to produce ammonia. Okay. So this is the reaction. Okay. So nitrogen is a gas. Okay. So you put a G to indicate that it is in gas, and hydrogen is also a gas. Then ammonia is a liquid. Okay, so this is a balanced chemical equation. Okay, this is the balanced chemical equation. Okay. F, state one use of ammonia. State one use of ammonia. So this one you are going to help me. Remember to put your answer in the comment section below.